So again, for this problem, we want to determine whether x is equal to 0 is an ordinary point, a regular singular point, or an irregular singular point. If it is regular singular point, we want to find the exponents of the differential equation. So again, to find the answer, we divide both sides of the equation by the coefficient of y double prime. So this is going to give us 0, and then we divide each term by x times 1 plus x. We get y double prime plus 3x 1 plus x plus 4x over x 1 plus x. So then this has a y prime and this one has a y. So now this is considered p of x. Oops, this is considered p of x, and this is q of x. And p of x is undefined at x is equal to 0 and at x is equal to 1, negative 1. And here x's cancel each other, so it is only undefined at x is equal to negative 1. So now the question was determine whether x is equal to 0 is ordinary singular or it's an irregular singular. So not negative 1. So that is our question. The question is about x equal to 0. So right now we know that x is equal to 0 is just the singular. But now we want to know if it's regular or irregular. To find out if it's irregular, we take the limit of x times p of x as x goes to 0. And then we take the limit of x to the power 2 q of x as x goes to 0. So now I'm just going to multiply x by 3x times 1 plus x. Take the limit as x goes to 0, but then x and x cancel each other. When I take the limit, I get 3, and we call this p0. That is the label I use for it. Then I'm going to take the limit of x to the power 2 times q of x, and q of x is 4x over x times 1 plus x. I could have just eliminated those. So, and then I take the limit as x goes to 0. I get 1 plus 0 in the denominator is 1. 4 times 0 is 0, so I get 0. And we call that q0. So since 3 and 0 are both finite, then we say x is equal to 0 is a regular. So x is equal to 0 is a regular singular point. Then it says go further. If it is a regular singular point, we want to find the exponent of differential equation. So to find the exponents of the differential equation, what we need to do is we are going to create this equation, r times r minus 1 plus p0 times r plus q0 equal to 0. So we substitute p0 and q0 into this equation and we solve. So I'm just going to distribute. I get r squared minus r. p0 is going to be 3r. 3 goes here. Q is 0. We put 0 here. We get 0. And then I get r squared plus 2r is equal to 0. We factor the r. We get r plus 2 is equal to 0. So either r is 0 or r is negative 2. So then you say the exponent of the differential equation at x is equal to 0 is that. So these are called the exponents of the differential equation at x is equal to 0.